Good morning, students. In the last class, we have discussed about the criterion stability of a closed loop control system. Today, we will discuss about the transient response of closed loop control system and their stability. As we have seen last class, the stability of a control system can be determined by identifying the location of the roots of its characteristic equation in a complex plane. If all the roots are located on the left half of the complex plane, or all the roots are having negative real parts, the system is stable. If any one of the roots lies on the right half of the plane or on the imaginary axis, the system is said to be unstable. So now let us see the sum of the transient response and its stability. Consider the first order system with unit step change. The transfer function is given by y of s equal to 1 by s into a by s plus a. Here the root s equal to minus a. That means it has a negative real part, and also the response lies between 0 to 1. For all the values of t, the output shows the values 0 to 1. That means the output is bounded for all the bounded input. Therefore, the system is stable. Now let us consider the transfer function y of s equal to a by s plus a. Here the response y of t equal to e power minus at. The roots are located on the left half of the complex plane. That means s equal to minus a. The response also exponentially decaying as e power minus at is there. The response is decaying exponentially. It shows for all the values of t, it lies between 1 to 0. Therefore, the response is bounded 1. Then we can say the system is stable 1. Now let us see the transfer function y of s equal to a divided by s minus a. Here the root becomes positive s equal to plus a. That means it lies on the right half of the complex plane. The response also exponentially increasing for all the value of t. The y of t is increasing with respect to time. Therefore, there is no bounded output in this case. So this system can be said to be unstable. Next we will see the sinusoidal response. Consider a second order transfer function. The transfer function g of s equal to 1 by s squared plus s plus 2. So here we can find two roots, that is complex conjugate roots. The one root is p1 equal to minus 1 plus j, and another root p2 equal to minus 1 minus j. So all the values of all the real parts of these two roots are negative. So it lies on the left half of the plane. The response also sinusoidally decaying. Therefore, the system also stable. Now let us see that the conjugate complex roots lies on the right half of the plane. As it lies on the right half of the plane, the response is sinusoidally increasing. There is no bounded output. Therefore, this system is called unstable. Now let us summarize all this case. Consider this diagram. Here the roots s is having minus a2 b2 and minus a2 minus b2. So it lies on the left half. Therefore, the response is bounded 1. The system is stable. The next s equal to minus a into 0. It's also lies on the left half. So it is exponentially decaying. The system is stable. For all the transfer functions which lies on the right half or on the imaginary axis, it is unstable. If it is lies on the left half of the plane, it is stable. Thank you very much.